Hello and welcome back to Principles of Statistics. I hope you've been able to review the lecture videos for Chapter 2. In this session, we will proceed to Chapter 3, which continues to deal with descriptive statistics and their numerical measures. For this first part, we will look at so-called measures of location. We will then look at the so-called measures of variability. One way to think of the measure of a location is that it's a statistic. It's a number that enables us to say where the data are, i.e. their location. There are several measures of location that we use: the mean, the median, the mode, percentiles, and quartiles. You will probably already be familiar with the mean, the median, and the mode, which we discussed during the first session. I should also note this point. We have to distinguish between so-called sample statistics in the gray box, population parameters in the green box, and point estimators. Remember the 6 students who stood up during the first day and who told us their heights? They're 6 of the 30 students in class that day. Hence, the 6 were a sample, and the larger group was the population. The average height of the 6 students which we computed, that's called the sample statistic. Now, if we had measured and computed the average height of all 30, then that number we would call the population parameter. Why do these distinctions matter? Because remember, usually it's hard to get information for the whole population. Suppose we were trying to measure how tall City College students were. It may be hard to measure all 10,000, so we'd measure only, say, 500 students. Then the sample statistic that we get from the 500 students, we use as a guide or as an indicator of the underlying data, which is the height of the population. And that's why, as you can see from the dark blue box, the sample statistic is the point estimator. It enables us to estimate the underlying data. So let's proceed with the mean. It's called perhaps the most important measure of location, and it gives us an idea of, if we are given a table of data, where is the center? In daily life, we also call the mean just the average. So all you do is, if you have a set of data, add them all up and divide them by the number of observations. Then that is the sample mean. The sample mean, in turn, is the point estimator of the population mean. That is, it gives us an idea of what the mean of the population is. So in mathematical terms, this is the formula for the sample mean. It's the summation of all values that's in the numerator divided by n, which is the number of observations. In this course, as in all statistics, we will be referring to the sample mean as x bar. The population mean, by the same analogy, is just the summation in the numerator of all the observations divided by big N, which is the number of observations in the population. The population mean we then call mu, which is the Roman letter mu, as opposed to, let's recall, as opposed to x bar, which is the sample mean. So here's an example. Suppose 70 apartments were randomly sampled in a small college town, and this table shows all the monthly rents. Please think for a minute, how would you calculate the sample mean? What we would do is add up all these values, and the total is in the numerator, which is 34,356, divided by 70, which is the number of observations, and that is the sample mean x bar, which in this case is 490.80. The median is another measure of location. Simply put, the median is the value in the middle when the observations are arranged in ascending order. So what you should do is arrange them from smallest to largest, look for the middle, divide the sample into 2, and whatever that number is that divides the sample into 2 is the median. Why is the median useful? Think, for instance, suppose you gather 10 people and ask them for their average income. Now suppose you suddenly include Mayor Bloomberg in the sample as the 11th person. What do you think will happen to the mean or the average income? As you may have guessed, the mean income will suddenly jump because 10 regular people, and you put in a billionaire, and you add all their incomes and divide by 11, you'll get something about $1 billion or something. So what's happening there is that the extreme value, Bloomberg's income, will raise the mean very much. In that case, the median will probably be more helpful, more useful. Here is an example of how to get the median. In the first row, you will find 7 observations, all mixed up. In the second row, we arrange them in ascending order. Because there are 7 observations, the middle observation is the 4th observation. As you will see, the value for that 4th or middle observation is 19. Hence, the median is 19. What if we have an even number of observations? For instance, here we have 8 observations. Again, what you do is arrange them in ascending order. Then look at the 4th and 5th observations, which are 19 and 26. Get the average of 19 and 26, which is 22.5, i.e., it's the value that's exactly in between 19 and 26. In this case, the median is 22.5. So here is an example. The apartment rents again. Now they're arranged in ascending order. Take note. So now let's look at the middle of the data. The middle will be somewhere in between the 35th and the 36th observations. What is the value for the 35th observation? 475. What is the value for the 36th observation? 475. What is the average of the two? 475. Hence, 475 is the median. Another way to deal with extreme values is using the so-called trimmed mean. All you do is you delete the, say, highest 5% values or the lowest 5% values. It depends on what you choose as the percentage. Take out all those and then do as before and compute the mean for the remaining values. The mode. This is the data set that comes up most often in your this is the number, this is the value that comes up most often in the data set. So for instance, if you have 10 observations and there are 3 that have the value 2, then 2 is the mode. Can there be more than one mode? Yes, because suppose there are 5 observations of 2 and 5 observations of 3, and let's say those are the most frequent, then yes, that's the data will be called bimodal. It has 2 modes. And actually there can be even more than 2 modes. In that case, the data are called multimodal. In this example, 450 occurs most frequently. It shows up 7 times, which is the most times for any observation. Hence, the mode is 450. What are percentiles? This tells us about how the data are spread. What we do is we arrange the data and then we divide them into percentiles, 1%, 2%, and so on. As you will note, we discussed the notion of relative frequency in chapter 2, and this is exactly related to that concept. You've probably encountered this in your exams or when you took the SAT and the grade you got put you in the, say, 85th percentile of students or 93rd percentile of students. All that meant is that 85% of the students had scores equal to or less than yours, or 93% of the students had scores less than or equal to yours. So again, what you do is you arrange the data in ascending order, compute the index, and sometimes you may have to do rounding up. So in this example, they arrange the apartment rents again. They looked for the 80th percentile. And the 80th percentile is actually at 542. And this is how we would interpret it. At least 80% of the items have a value 542 or less. But as you will note from the right-hand side, that also means that at least 20% will have a value of 542 or more. Quartiles conceptually are like percentiles. It's just that what we do is we divide the data into 4 groups, i.e. 1/4 each. So in this case, as you will see from the calculation, the 3rd quartile is 525. What's another way to interpret this when we say that the 3rd quartile is 525?